It is one of the oldest questions mankind has ever asked. Are we alone in the universe? With the universe as vast as ours, could it really be true that we are the only ones in it? Surely, there must be some other inhabited world out there. In the 19th century, the question became more specific. How common was life exactly? Could it be common enough to have arisen multiple times in our own solar system? Could it exist, say, on the planet, most similar to our own? Could there be life on Mars? Speculation raged, and sci-fi writers imagined entire alien civilizations on the red planet. Although this speculation has diminished in the last century as our first probes and satellites went there and sent back photos of nothing but barren deserts, the question didn't entirely vanish. It simply reframed itself. Could life have once existed on Mars? Not now, but in the ancient past. For all of our inquiring, to this day, it is a question that only has one answer. Maybe. Thanks to probes that have gone before, we know that liquid water once existed on Mars, and where there is liquid water, there is the possibility for life. This was an incredible discovery when it was made in the 1970s, but it is not proof. It's a question that, if answered positively, would forever alter our entire view of the universe. Because if life arose twice here in our solar system, it almost certainly arose elsewhere. But until we find that first fossilized example of life on another planet, we will not know for sure. So NASA said, let's become sure. This is a video about the rover that went to check. I'm Alex McColgan, and you're watching Astrum. Join me today in this supercut as we delve into the first campaign of the Perseverance Rover, the NASA machine tasked with actually collecting samples of fossilized microbial life on Mars to return to us before the decade is out. This could be the rover that finally lays the ancient question of are we alone to rest. So how did that first campaign go? Perseverance launched on the 30th of July 2020 on an Atlas V rocket. There was a great launch window around this time where Earth and Mars were aligned just right for a quick rendezvous. In fact, China and the UAE also launched a rover and probe, respectively, during this same launch window. The cruise took 7 months, and checks on the system showed that Perseverance was in good shape for the atmospheric entry. Landing is the most nerve-wracking part of the whole journey. The extremes in temperature and speed involved make it very dangerous. NASA has had a lot of practice at it, though, and seems to be getting better and better every time. NASA has this cool visualization on their website that I want to show you because I want you to appreciate that landing a car-sized rover on another planet is no mean feat. First, about 4,000 kilometers from the landing site and traveling over 16,000 kilometers per hour, the cruise stage is detached and thrusters are used to stop the craft from spinning. At an altitude of 120 kilometers, the craft has sped up to over 19,000 kilometers per hour, but it's here that the Martian atmosphere begins slowing Perseverance down. Due to turbulence in the atmosphere, thrusters are being used to keep the spacecraft steady and to keep the heat shield facing forward, as friction from the atmosphere heats the shield up to over 1,300 degrees Celsius. Computers on board are autonomously monitoring its position, keeping it aimed at its final landing goal. At 60 kilometers up and 16 kilometers from the target, the atmosphere has slowed Perseverance down to 3,000 kilometers per hour. Now, this is where things start to get interesting, as the spacecraft was fitted with a number of video cameras, giving us an unprecedented view of the landing sequence. First, the huge 21-meter parachute was deployed. You may notice the odd pattern in red and white. This is useful for scientists to see the orientation of the parachute. But there's also a hidden code in there. Dare mighty things, the NASA Jet Propulsion Laboratory's motto, written in binary code, with the GPS location of JPL on the outside. At 10 kilometers up and having slowed to 600 kilometers per hour, the heat shield is released, reducing the weight and exposing Perseverance to the Martian atmosphere for the first time. At around 4 kilometers up, the spacecraft begins imaging the surface to search for a safe place to land. At 2 kilometers up, once it's happy with the landing spot, the upper casing of the spacecraft separates, leaving just Perseverance and the rocket-propelled descent stage. Rockets are necessary as the parachute can't slow the fall anymore. Mars's atmosphere is simply too thin. The rocket stage slows the fall from 300 kilometers per hour to zero, and it hovers 20 meters above the surface. The rover itself is then lowered using cabling suspended by what is known as the sky crane. Once it's safely on the ground, the rocket stage cuts loose to crash a safe distance away. How amazing is that? And actually, being able to see it is incredible. After a 7-month journey, Perseverance landed on the surface of Mars on the 18th of February, 2021. Perseverance is NASA's most ambitious rover yet. To give you a sense of scale, the thing is massive. NASA has basically sent a car to Mars. You may notice, though, that its looks are heavily based on its famous predecessor, Curiosity. While it may appear almost identical, there have been some major improvements to the design based on what didn't work so well on Curiosity. One noticeable difference is the wheels. Curiosity's wheels have shown some serious wear so far, so Perseverance's wheels are thicker and more durable. They are also less wide, but have a larger diameter. Another improvement is its robotic arm, which is longer and stronger than the one on Curiosity. But the most notable differences are, unsurprisingly, the scientific instruments on board. Because while Curiosity was designed to investigate whether Mars was once a place conducive to life, Perseverance is looking for actual evidence of fossilized life. The first step for it will be to find compelling rocks, and it has an advanced suite of instruments to help it do just that. On the mast is a powerful camera called the Supercam, which uses a laser to identify the composition of rocks. The camera itself takes a photo to visually identify what the laser is pointing at. So it's not actually this camera that takes the impressive panoramas you'll see later. However, this instrument is really important. It can analyze a rock from several meters away, which means the rover itself doesn't need to move within arm's reach of a rock it wants to identify, allowing it to move on to a new region quicker. The 3D panorama cameras are also located in the mast, and they can zoom, focus, and take video. Once intriguing rocks have been identified with cameras, Perseverance can move in closer and examine them with the spectrometers in its arm. There are 2 cameras in the arm, a normal color camera, called Watson, and another laser camera, which can also take microscopic images, called Sherlock. Interestingly, I found these images in the raw files of the cameras, and upon investigation, it turns out they brought this along to test the camera's focusing, and that the laser reads the material correctly. There are various materials on the rover, including spacesuit fabric, and some with Sherlock Holmes Easter eggs. For example, this has a maze on it, with a tiny Sherlock Holmes image in the middle, and this rock sample has 221B Baker written on it, the famous address in the books. Apparently, one of these rock cross-sections is actually from a suspected Mars meteorite. If true, it would be the first known instance of a rock from Mars doing a full round trip to Earth and back. Another of the instruments is basically a weather station, an instrument that will keep track of the wind, temperature, humidity, pressure, and dust levels. Towards the back of the rover, there is a ground-penetrating radar instrument which will be used to see the geologic features under the surface. There is also a rather special experiment module, MOXIE, that will be used to see if oxygen can be extracted from the Martian atmosphere, a crucial necessity for the survival of future human colonies, and surprisingly, even a way to produce rocket fuel. Leaving a planet's gravity naturally takes a lot of fuel. For Mars's lighter gravity, it still requires 30 to 40 metric tons of propellant. It's even harder to do on Earth, and becomes harder still if you have to also carry all the fuel you will need to make the trip home again. However, knowing that we might be able to make most or all of that fuel from liquid oxygen found on the planet makes space travel much more feasible. The last experiment on board relates to Perseverance's primary objective: finding compelling rocks that may host microbial fossils. Once the cameras and spectrometers have identified promising candidates, the arm is equipped with a drill that can either abrade the top layer of a rock to expose the unweathered surface beneath, or if the mission team wants to extract a sample from the rock, the drill can also core out a chunk. The arm will feed the sample through to the body of the rover, where a second arm will move the core to a place where it is sealed and then stored in one of 20 caches that will be on board. Interestingly, although Perseverance was cleaned as much as possible before launch to avoid contaminating Mars and these samples, even tiny traces of gases from the rover itself could skew readings. To combat this, there are also some witness tubes that are preloaded with witness materials that can capture molecular and particulate contaminants. Each witness tube will be opened on Mars to capture the ambient environment. They will then be sealed like the normal sample tubes. Comparing the witness tubes with the catched samples will allow scientists to know what the contaminants are and eliminate them. But sadly, Perseverance will not be able to confirm the existence of microbial life by itself. It is actually designed as a forerunner mission. Once Perseverance has filled all the caches, it will place them for another mission to pick up. NASA wants this to be a sample return mission. However, the means of collecting these samples has not been finalized yet. A launch is currently slated for 2026, using a rover to pick up the samples and deliver them back to a rocket, where this rocket will rendezvous with an orbiter, which will make the journey back to Earth with the samples in our hands by 2028. It's a very complicated system, so let's hope the mission teams will really get everything right in the coming years. As the rover turned on its cameras and took in its surroundings for the first time, it found itself staring out across the red, arid, and solitary landscape that we have come to expect from Mars. The terrain around it was mostly flat, albeit interspersed with rocky outcrops. This was intentional. Scientists had deliberately brought Perseverance to a place where its wheels could transport it freely, and where it could find sites of particular scientific interest. To that end, they had chosen Jezero Crater. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods without needing to do major drilling, helping scientists piece together the geological history of Jezero Crater and get a better picture of the most likely locations to find life. It would spend some time investigating the sections of Jezero crater near its landing site in what is known as the Crater Floor Campaign, before moving on to the Jezero Delta as part of the Delta Front Campaign. You would think that Perseverance would be on the move almost immediately, eager to begin its mission. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods, giving it plenty of opportunity to get started on its search. However, you would be wrong. Despite landing on Mars in February, it wasn't until nearly 5 months later that Perseverance made any major effort to leave its landing site and begin its journey. And this was not just because scientists took time carefully testing every single piece of scientific equipment and its software to make sure everything was working smoothly. You see, Perseverance was not alone. In fact, it may surprise you to discover, but you might say it was because Perseverance was pregnant. Cradled in Perseverance's undercarriage, hidden by a dust shield from the Martian winds and atmosphere, Perseverance had brought with it a second, smaller passenger to Mars. Much of the initial few months of Perseverance's time was spent helping bring that second passenger into the world. This second passenger was to be Perseverance's companion for the journey ahead, as well as an interesting tech demo. This smaller robot was not a rover. Its name was Ingenuity, and it was the first ever attempt at a helicopter on Mars. After performing several tests on Perseverance's own software and hardware, scientists turned their attention to this smaller 1.8-kilogram drone. The atmosphere on Mars is about 100 times thinner than Earth's, making it uncertain whether a helicopter's spinning blades would even work there. It would be difficult to displace enough air to create lift. Ingenuity was incredibly lightweight to compensate for this, and its rotor could spin at revs of over 2,000 RPM. Its only scientific equipment was a camera, but this would be invaluable in helping Perseverance find the best routes through the potentially tricky Martian terrain. So on the 21st of March, nearly a month after landing, the berthing began. Perseverance started by removing its dust shield, allowing Ingenuity to taste the Martian air. Mechanical berthing is a slow process. However, with scientists constantly checking every single piece of data to make sure everything is functioning as it should. It wasn't until the 3rd of April that Perseverance finally placed Ingenuity on the hard Martian soil and allowed it to experience its first cold night on Mars. Temperatures on Mars reach lows of -100 degrees Celsius, so outside of the protective heaters of Perseverance, Ingenuity faced a harsh environment. It's no small thing that Ingenuity survived the night with no problems, but scientists were delighted that this part of the mission went smoothly. During this stage of Perseverance's mission, it looked on like a proud parent as Ingenuity began to take its first wobbling steps. Although just like a parent, Perseverance couldn't resist taking a selfie or two to show off to its friends on Earth. Ingenuity's first flights did not go completely without a hitch. After taking time to test its rotors at varying speeds, Ingenuity did run into some software issues that worried the engineers who worked on it. However, by the 19th of April, Perseverance was able to record as the solar-powered drone attempted the first ever controlled flight on another planet. The flight was done autonomously, as the time it would take for a signal to travel from Earth to Mars would create too much lag to try and fly remotely. There were a lot of unknowns. Mars has lighter gravity compared to Earth, as well as thinner air, which meant that testing the rotor on Earth didn't necessarily mean it would work on Mars. It's hard to properly replicate lower gravity on Earth, for example. But fortunately, and with incredible smoothness, Ingenuity rose to an altitude of 3 meters and remained hovering there for 39.1 seconds, just as planned. Scientists were very excited when the tech demo that had been proposed just 6 years earlier proved itself a success. Ingenuity was not expected to last long on Mars, but it kept going and going, flying further and higher than every previous attempt. It didn't crash, didn't break, and actually became a useful scout for Perseverance, helping to find good routes for the rover to take, or to search for points of interest too small for satellites to detect. Ingenuity went from a disposable tech demo at the beginning of the mission to a valuable aid and accomplice for the Perseverance rover. What about Perseverance? The Martian rover was not completely idle during this time. Perseverance was able to test out a lot of its own gear while it waited for Ingenuity. Perseverance was equipped with a microphone, and scientists hoped to get the first ever audio sample from the Martian surface. Soon after landing on Mars, Perseverance was able to do just that, giving us our first idea of what the wind on Mars sounds like. It certainly adds to the desolate feel of the landscape. Perseverance also spent time driving short distances to test its motors, took panoramas of the surrounding landscape, and even successfully extracted oxygen from carbon dioxide out of the red planet's atmosphere using its MOXIE instrument. MOXIE, which stands for the Mars Oxygen In Situ Resource Utilization Experiment, managed to produce about 10 grams of oxygen in 1 hour, which is not that much. But to be fair, MOXIE is only a prototype about the size of a car battery. It would need to be 100 times larger if we were to actually use it on the red planet to support human interests. However, just knowing that it works is an exciting step forward. But as fascinating as all these things are, there was one thing that Perseverance still needed to do. It had come here to discover one very important thing: was there ever life on Mars? And so, during this period of downtime, scientists were busily plotting the best possible route for Perseverance to take. Although Perseverance's landing was one of the most accurate Mars landings NASA had achieved so far, it was still many days' travel from some of the 40-meter-tall outcroppings of rock at the edge of the crater known as South Sator that scientists wanted to investigate. Between South Sator and Perseverance's landing site, there lay a dangerous dune field filled with loose sand, impossible for the rover to cross without risking getting stuck forever, which would spell an end to the mission. Scientists would need to decide the best possible route around the dunes. Was it better to travel anti-clockwise around the crater, which would get Perseverance to the outcroppings faster? Or would it be better to travel clockwise, which would take longer, but would allow the rover to stop by more interesting rocks along the way? In the end, as is often the case in the space exploration, it came down to efficiency. Scientists chose the second option to allow it to do as much science as possible in as many areas as possible in the limited time the rover had available to it. Perseverance was finally given the go-ahead, and so, on the 1st of June, almost 5 months after arriving on the red planet, Perseverance's wheels trundled into life, and the rover finally left the safety of its landing site and set out on its primary mission: to collect core rock samples from locations where life could potentially have flourished for ultimate return and analysis to Earth. The search for alien life could now begin in earnest, with Ingenuity following along to keep Perseverance company, of course. Millions of years ago, a massive object had crashed into the surface of Mars. The resulting crater was hundreds of meters deep and 40 kilometers in diameter. Due to the different geological conditions that existed back then, it soon began to fill up with water. In time, this crater became a massive lake and earned the name Jezero, which somewhat unimaginatively literally means lake in some of the Slavic languages. Massive rivers began to run into the Jezero crater, carving valleys through the terrain and depositing all the resulting silt over huge deltas. This is why Jezero was selected as the site for Perseverance's mission. If life worked the same way here as it does on Earth, this location could be rife with possibilities for the emergence and propagation of life. As Mars is now a barren wasteland, the kinds of things Perseverance is looking for would not be immediately obvious. Any life that swam in Jezero's lake would have lived, died, and fallen to the lake bed, where accumulated silt from the river would have buried it in the hard rock. Perseverance would need to make good use of all the tools at its disposal: its drill-mounted arm, its ultraviolet spectrometer Sherlock, and its X-ray fluorescent spectrometer Pixel to find this evidence. However, it is important to choose targets carefully. Perseverance has limited resources available to it. It only has just over 30 sample tubes for storing rock cores for the return journey home. Tempting as it might be to just grab a sample from right where it landed, Perseverance needed to only collect samples from the locations most likely to provide evidence of signs of life, or offer particular insight into the formation and age of Jezero crater, to pinpoint better possible locations for later. As such, Perseverance did not start drilling immediately, but instead began traveling south from its landing location at Octavia E. Butler Landing, named after the science fiction author, to the area known as Crater Floor Fractured Rough. Although this location was less than a mile away from Perseverance's landing site, Perseverance would not arrive at this new location for nearly 60 days. This is because the unfamiliar, rocky surface of Mars is strewn with obstacles for a rover. You'll notice the rocks that are scattered over the Martian surface. Perseverance would need to pick its path carefully around these, as the rover's 52.5 centimeter diameter wheels can only drive over objects that are so large. Soft terrain poses just as many dangers. The previous Martian rover, Spirit, came to an unfortunate end after getting stuck in a sand dune, so choosing its path is a balancing act. Not too hard and rocky, but also not too soft. In the past, these decisions would have been made on Earth, with a 20-minute average signal delay. No wonder the previous rovers had traveled so slowly. However, Perseverance had gotten an upgrade compared to Spirit and Opportunity. Advanced AI software called AutoNav on the Perseverance rover allows it to map out its surrounding environment and choose for itself the best path through it. Although there is still some oversight from Earth, this greater degree of independence, which Perseverance can do on the fly while driving, allows the rover to travel much faster than the rovers before it, allowing for more science to get done. And speaking of science, on the 20th of July, Perseverance successfully managed to navigate its way to Crater Floor Fractured Rough. Taking things slowly, scientists picked out a rock to first test Perseverance's abrading drill systems. The abrading attempt took place on a paving stone nicknamed reshaped, and it was a simple success. The drill cut away the top and gave scientists insight into the kind of stones that Perseverance was driving on. By examining grain sizes, chemical composition, and other details, scientists would gain insights into the type of rocks these were, either sedimentary, the kind likely to contain fossilized remains and other artifacts, or igneous rock, formed from magma. What they saw heartened them, and on the 6th of August, scientists picked out another target rock, nicknamed Rubion, to take their first actual core sample. Due to the time zones involved, it was only 2 a.m., Pacific Daylight Time, when over 90 engineers and scientists gathered online to witness the fruits of their years of labor. Perseverance drilled successfully down to the 7-centimeter depth it had been programmed to reach. It photographed the hole afterwards, and everything seemed to be going fine. Over the next 6 hours, Perseverance painstakingly took the core, placed it in one of its tubes, and moved it to its adaptive caching assembly, the place where core samples are processed. Due to the nature of the mission, it's vitally important that no contaminants be allowed to enter the tube, or else it might invalidate the entire process. Finally, Perseverance transferred the now sealed tube to its storage unit. Scientists were elated at this perfect first-time success. But then more data came through, and scientists realized that there was a problem. The sealed tube was empty. Confusion filled them. Where had the sample gone? Due to the limits of technology, scientists could not record on camera